transformer. Transformers don't read text from the start to the finish. They soak it all in at once, in parallel. The very first step inside a transformer, and most other language models for that matter, is to associate each word with a long list of numbers. The reason for this is that the training process only works with continuous values, so you have to somehow encode language using numbers, and each of these list of numbers may somehow encode the meaning of the corresponding word. What makes transformers unique is their reliance on a special operation known as attention. This operation gives all of these lists of numbers a chance to talk to one another and refine the meanings that they encode based on the context around, all done in parallel. For example, the numbers encoding the word bank might be changed based on the context surrounding it to somehow encode the more specific notion of a riverbank. Transformers typically also include a second type of operation known as a feed-forward neural network, and this gives the model extra capacity to store more patterns about language learned during training. All of this data repeatedly flows through many different iterations of these two fundamental operations, and as it does so, the hope is that each list of numbers is enriched to encode whatever information might be needed to make an accurate prediction of what word follows in the passage. At the end, one final function is performed on the last vector in this sequence, which now has had a chance to be influenced by all the other context from the input text, as well as everything the model learned during training, to produce a prediction of the next word. Again, the model's prediction looks like a probability for every possible next word. Although researchers designed the framework for how each of these steps work, it's important to understand that the specific behavior is an emergent phenomenon based on how those hundreds of billions of parameters are tuned during training. This makes it incredibly challenging to determine why the model may